For the video on 1.5, we're going to describe angle pair relationships. So again, there's going to be a bunch of definitions in here, but they won't be too bad. So the first one is adjacent angles. So adjacent angles are two angles that share the same vertex and side, but they have no common interior points. And what you have to think of with that is that they are not overlapping. So here is a picture of what adjacent would look like. And here is what non-adjacent would look like. So complementary angles are when you have two angles that have a sum of 90 degrees. And each angle is the complement of the other. Okay, so if we have adjacent complementary angles, that means that they would have to add up to be 90 degrees and they have to share a vertex and a side. And this is what your picture would look like. And if you notice in my picture, that there's this little box right here, and that shows that it's 90 degrees. And then I just divided it up. It doesn't matter where your ray is in the center. And then 1 and 2 would be my two complementary angles. So 1 is the complement of 2 because they would add up to be 90 degrees together. So here's my picture of non-adjacent complementary angles. And you can see that the 60 and the 30 degrees add up to be 90 degrees. So they are complementary, and they are a complement to each other, or to the other one. But they do not share a vertex and they do not share a side. So next is supplementary angles, and it's very similar, except it's when two angles have the same or have a sum of 180 degrees, which means that each angle is the supplement of the other. And our pictures would look very similar, except the adjacent ones need to show that they are 180 degrees, and this is what my picture looks like. So you can see that it makes a straight line right here. So remember, supplementary, if you think of a protractor, the straight edge all the way around is 180 degrees. So that means if I divide that up into two different angles, those two angles would add up to be 180 degrees. So my non-adjacent angles would look like this. So you can see that the first angle is an obtuse angle, and it's 120 degrees. My second angle is 60 degrees, and it is an acute angle. But together, they add up to 180. All right, in this question, we're going to go through and name one pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So you really have to look at what the degrees are for the different angles, because the degrees are going to tell you which of those pairs we have. So adjacent angles, they don't need to add up to be any certain number for the degrees, but supplementary and complementary do. All right, so the complementary angles have to be adding up to 90 degrees. So if you look at it, we can't use this angle of 120 degrees, so it's probably will end up being the other two. And if you check, 32 plus 58 does equal 90 degrees. So remember, we have to label them with 3 letters. So the first one can be angle BAC. The second in the pair would be RST. So you can see that the 32 plus 58 does equal 90 degrees, so that is the one pair of complementary angles. So next is supplementary. Supplementary have to add up to 180 degrees. So we can't use just the 58 and the 32. We're going to have to use 122 with one of those two angles. So 22 plus 32 is only 54, so that would only be 154 degrees. So we'd have to use the 122 and 58 degrees. Those two angles would then give us a supplementary angle together. And you can see that if we add up the two numbers, so 122 plus 58 does equal 180. So our supplementary pair will be angle CAD and angle RST. All right, so next is adjacent angles. So adjacent angles just need to share the vertex and a side. So the only pair that even has that is these two right here. So those would be the two angles that make up our pair of adjacent angles. So in these two first questions, I would like you to try them on your own. So it's just like the ones we just did together, but now you can try them out on your own. Remember to check your answers after you are done. All right, now that you're ready to check your answer, your complementary angles have to add up to be 90 degrees, so that would be FGK. So our angle 41, or degrees, 41 degrees, and angle GKL, which is 49 degrees. So 41 plus 49 does equal 90. Next would be our supplementary angles, and that would be GKL, so our 49 degrees again, and KGH, which is 131 degrees. So 49 plus 131 gives us 180 degrees, and those two would be our supplementary angles that make up a pair. All right, lastly, we have adjacent angles, and remember, adjacent angles have to share the same vertex and share one side, but they cannot overlap each other. So the only two that would make sense would be our angle 141 and 131. So FGK and HGK would be the only two that would give us an adjacent angle pair. For number 2, where it says that our KGH, so this is 131 degrees, and LKG adjacent angles. And that would be a no, because they do not share a vertex and a side. They only share a side in common. So they don't share the vertex, which needs to be that middle letter. So then next, angle FGK, so 41 degrees, and FGH, that would be both of these added together, so that would be 172 degrees, so the whole angle all the way across. Would those be considered adjacent angles? Well, they do share some things in common. They do share the point G as the vertex. They do share a side, so like the FG, there would be a side that they share in common, but one thing you have to remember is that they cannot overlap. So they can't have points within one angle that is also within the other angle. So that would be also that no, they are not adjacent angles. So in this slide, we have to pay attention to the words complement and supplement. So the first one, complement, means 90 degrees. And it means that the two angles are added together, add up to be 90 degrees. So that means that angle 1 and angle 2 will add up to be 90 degrees. Because of this, we can put this 68 degrees in place of angle 1. And then we can solve for angle 2. So we would subtract both sides by 68. So angle 2 would equal 22 degrees. So we're going to say the measure of angle 2 equals 22 degrees. So the second one is very, very similar, except it is supplement, and that angle 3 and angle 4 is a supplement of each other, which means they add up to be 180 degrees instead. So this is what your equation would look like. The 56 then is in place of angle 4, so we'd have angle 3 plus 56 equals 180, and then you can subtract your 56 from both sides, and you would end up with angle 3 is equal to 124 degrees. All right, so in this problem, it's going to be very similar to the last one, except that we have variables that we are dealing with. So if you look at the ground, that this ball return net makes a supplementary angles with the ground. So there's two separate angles here that are formed, and they are supplementary. So we know that supplementary means that we have to add up some angles to equal 180 degrees. So we're going to add up those two angles formed to equal 180 degrees. Once you have your equation set up, then all we have to do is substitute those values, the 4x minus 8, into the angle BCE. And the angle ECD, the x plus 2, we need to substitute that in for then the angle ECD. Alright, so just like the other one, we can solve this for x. We can combine our x's together, so we have a 5x. Combine our constant together, we have a plus 10 equals 180. Subtract our 10 from both sides. So we have a 5x equals 170. We can divide both sides by 5, so our x ends up being a 34. Sorry, that's a little sloppy there. So remember, we have to plug it back in to find what those individual angles are going to be. So what I would like you to do is push pause. I want you to work out that portion of it, and then when you're ready to check your answer, push play. Alright, so now that you're ready to check your answer, this is what your answer should be for angle BCE. So we should end up with our measure of angle BCE is 144 degrees. Your answer for angle ECD should be 36 degrees, and here's the work for it. Here are the next 3 questions that I would like you to try, and you've got one of each like we just did. And in number 5, if you notice, there's no picture drawn, but you can draw a picture through this that is showing 2 complementary angles. The biggest part is that they are complementary, so you have to think of what they add up to be. So go ahead and work out all 3 of them. When you're ready to check your answer, then go back and push play to listen to it. All right, so for number 3, you should end up with angle 1 is 82 degrees, and this is the work that you should be showing on your paper. For number 4, with the supplement or supplementary question, your angle 4, measure of angle 4, should end up being 63 degrees, and here's the work that you should be showing on your paper. For number 5, all you need to realize is that they are complementary angles, so that they need to add up to be 90 degrees. So this is what your work should look like to solve for x, and x should end up being x equals 7. So after you got that x equals 7, you have to put it back into both of the two individual equations because you need to figure out what those individual degrees will be. So together they should add up to be 90 degrees, but you want individual. So the first one of angle LMN, that one should come out at 26 degrees. The next angle, angle PQR, should come out at 64 degrees. And if you do a mental check, you can see that 6 and 4 gives you 10, 6 and 2 gives you 8. So another 10 more from the 6 and 4 when it's carried over does give you the 90 degrees that you need for the complementary. All right, so this page is just straight two definitions. The first one is two adjacent angles for a linear pair. So a linear pair is two adjacent angles where the non-common sides, so the part that they don't share in common, are opposite rays. And if you think about that, this is the picture that it creates down here. So angle 1 and 2 make up a linear pair. So they are two adjacent angles, and the non-common sides, that would be this side right here and this side right here, that they make opposite rays. And if you look at it, that means that these two angles then will be supplementary. So if two angles are a linear pair, we know they're supplementary. And because they're supplementary, then we know that they will add up to be 180 degrees as well. So next are vertical angles. Vertical angles in our picture down here would be 3 and 6 and 4 and 5. And how we can describe that, it's where two angles, when their sides form two pairs of opposite rays. The biggest part you want to remember though also is just where they show up in your picture. So 3 and 6 are opposite angles in a sense, but they're vertical angles, and then 5 and 4 are the vertical angles that are in there. All right, so for this question, we're going to go through and list out which angles are linear pairs and which ones are vertical angles. So a linear pair, remember, needs to have the non-common sides, so the sides that they don't have in common, need to make an opposite ray. So if you think of, here's one line, are there two angles that are formed on either side of this? And that would be 4 and 5. So 4 and 5 would be a set of linear pairs. Another set of linear pair angles would be 1 and 4. So if you see this line right here, that 1 and 4 make up two of the angles on that one side. So angle 1 and 4 will be another linear pair. For the vertical angles we want to look for any angles that are created by two intersecting lines, and it's the opposite corners of them. So this line doesn't connect with anything on the other side, so we can't use that one. So we'd have to look at these two full lines where we have actually opposite rays in there as well. So those two lines, that 5 and 1, are two angles in opposite corners of those that are created. 2 we couldn't use with the 4 because we'd have to use this one. It would have to go all the way through the 4. And 3 we can't use the 4 or 1 because they're not going to be the exact opposite. We don't have this line that's creating it that goes through another line. So it would only be angle 1 and 5 are the only two that are vertical angles. This is the last type of question that we're going to do. I'm going to do this one with you, and then you're going to do two last questions by yourself. So in this one, we have two angles that form a linear pair. So you have some definition words you have to pay attention to. The measure of one angle is 5 times the measure of the other. So let's stop right there. How about we draw a picture first for the first sentence. We have two angles that form a linear pair. So remember, a linear pair, we have to have an opposite ray, and we need to have two angles that are created in there. So there's my two angles. So 1, 2. The measure of one angle is 5 times the measure of the other. So we have one that's bigger than the other one, and it's 5 times the size of the other one. Well, we don't know what this other one is, so let's label that as an X. So if this one is an X, and this larger one is 5 times that, then that needs to be labeled as a 5X. So we need to find the measure of each angle. Well, it doesn't tell us any other numbers other than we know that they form a linear pair. So you have to remember, a linear pair means that they are then supplementary, and we know supplementary is 180 degrees. So the equation that we would end up setting up would be 5x plus x would have to equal 180 degrees, and then we can solve this. So we can combine those together. Remember, there's really a 1 in front of our x, so we have a 6x. And then we can divide by 6. So 180 divided by 6 gives us 30. But remember, they want each angle, so we wanted to plug that back in to both of those parts just like we have before. So for the x angle, we know that's just going to be 30 degrees since that's by itself. For the 5x, we have to take our 30 degrees and then might multiply it by 5. So we would end up with 150 degrees would be the size of that angle. So 30 degrees and 150 degrees are the two measures of those angles. And if you double check, if we add those together, they do create 180 degrees, which would match this picture. So these are the last two questions, and you're doing these on your own. So go ahead and push pause, work them out, and then check your answers when you're done. All right, so the first question, number 6, do any of the numbered angles in the diagram at the right form a linear pair? And the answer is no. So remember, a linear pair, we need to have only 2 angles are formed on one side of these, and a bunch of these, they all have 3 angles on one side. So that would be a no. And then which angles are vertical angles? There are actually 3 different sets. So one set, it would be 2 and 5. Another set would be 3 and 6. The other set would be angle 1 and angle 4. So then going on to number 7, the measure of an angle is twice the measure of its complement. So complement means it's 90 degrees together, and it's kind of like the last question we did with the supplement. So you need to draw a 90-degree angle, and if one of them will be an x, then the other one has to be twice that size, so it would be a 2x. This time we know it equals 90 degrees, so you should have 2x plus x equals 90. We can add those two together, so we end up with a 3x equals 90. Our x, when we solve it, ends up with 30. But again, we have to plug it back in because they want each individual angle. So when you plug that back in, you get 30 degrees for one, and the other one has to be double that, so it would be 60 degrees. And they do add up to be 90 together, and the one of them is double the other size.